Right, these couple of videos, 3.1b to 3.1e, 3.1f rather, are all based on AP Precalculus FRQ style questions. So this is, I think, FRQ number 3. That's how they ask us on periodic phenomena. Steve and his friend are playing together on a seesaw as shown at time t equals 0. The distance between the top of the Steve's head uh, and the ground is 24 inches. So this is uh, at the highest point. Okay, no, okay, I see. Steve's head is 60 inches above the ground at the highest point. So this is the starting point, and this is 24 inches, and then it's 60 inches. Steve goes all the way up and down on a seesaw every 3 seconds. So that is the time period. As the two friends play on the seesaw, the distance between the top of Steve's head and the ground periodically increases and decreases. And this periodic model D is modeled over here as a function of time. So they are saying that two full cycles are drawn here, and these are the 5 points, and we have to determine the possible coordinates of all these points. Okay, so what is the minimum height of Steve's head? Obviously, that's 24, right? Because that's the starting point. So that has to be 24. So the minimum height is 24. And what is the maximum height? The maximum height is, I think they have given that to 60 inches, right? 60 inches. And what is the period? That's already known to us. It's 3 seconds. So what will be the middle value? Because after all, the dotted line is the middle line, right? So what will be the middle value of this? Um, okay, all right. So the middle value is going to be obviously 60 plus 24 divided by 2, which is 84 divided by 2, which is 42 inches. So that's the midline. So one thing is for sure that j corresponds to the minimum value. So it's x coordinate that we have to find. The y coordinate has to be 24. K and G corresponds to the midline, so it has to correspond to something comma 42, right? Something comma 42 and something comma 42, and finally the highest points correspond to the highest value, which is 60. So something comma 60 and something comma 60. Now the starting point is the minimum point, right? So we know that that is t equal to 0, but I cannot consider the minimum point as 0. Otherwise, these 2 points will have a negative time. That doesn't make any sense. So if t equal to 0 is that starting point, when next will Steve be in this position? Obviously, that has to be after 3 seconds because that's when it repeats itself, right? So after 3 seconds. So I know that this has to be 3. And how many portions do we see? Like in how many phases this is being divided? It's like 4 phases, right? For example, here to here 1, then 2, and then 3, and then 4. Obviously, that's 4. So this three time period of 3 is divided into 4 equal pieces, and 3 over 4 is 0.75. We know that 3 over 4 is 0.75, which means that you go 0.75 units back from here, it will become 2.75. You again go, you go 0.75 units here, so it will become 2.25. You go 0.75 units back again, so it will become 1.5. You go 0.75 units forward to become 3.75, and then again forward to for it to be 4.5. So this is how a possible set of coordinates would look like. I think all the 5 points are mentioned over here. Now they're asking that refer to the graph D, the between F and G, that's what we have to measure. I mean, that's what we have to look at, F and G. So F and G is clearly over here. In fact, let's look at this one. F and G is clearly over here, right? So between F and G, is the function positive or negative? That's their first question. So obviously that's positive because everything is positive, right? Y values are positive, so it has to be positive. And whether it's increasing or decreasing, obviously between from F to G, the function is decreasing in nature. So it has to be positive and decreasing. And how's the ROC changing between T1 and T2? So as you can see, between F and G, it's frowning phase. So it's concave down, right? And if it's concave down, frowning phase, so ROC is decreasing in nature. ROC is decreasing in nature. That would be our answer to this question.